Hi everyone, and welcome to today's SQL Office Hours. Today we're going to start off a bit of a back to basics series. I thought, we've covered some in-depth topics in these sessions, but I thought we'd go back and look at some of the more fundamentals of SQL because they're things we use every day, and there are some little details of them which we've probably overlooked over time. As I say, please put your questions in the Q&A window and I'll do my best to answer them as the session goes on. And so without further ado, let's get started. Okay, so the basics of insert are pretty straightforward, really. I mean, it's a very simple statement. We just got insert into whatever the table name is, and then a list of the columns we want to supply values for and what those values are. So pretty straightforward, right? Well, as I said, there are various details and bits and bobs to be aware of with this. So first thing to note here is this column list is optional. So you do not actually have to specify it. You have to say what the table is and what the values are, but you don't have to say what the column list itself is. So we can do something like this. You can create a table and just insert a whole list of values to that. And as I said here, this assumes that you're going to provide a value for every column in the table. Now, I put a little asterisk there. I'll come back to exactly why there's an asterisk for that in a bit more detail. But basically, when you've got an insert with without a column list, you're providing values for every column in the table. This is a bad idea. Well, why? Well, what happens if we go and change the table? Let's add a column to it. We try and run the same insert statement. What's going to happen? We've got 3 columns, but we're only providing values for 2 of them. So the whole thing falls over in a nice big heap. Well, I say nice, in a big heap that you don't really want. Not good if you just deployed this column change to production and then some code out there which has inserts without specifying what the column lists are. So it is very good practice to provide those column lists for the insert every single time, along with all the individual values. So that's easy for me to say, just type all these things out here. But tables can have a lot of columns on them. And some of you at this point might be thinking, I got some of these tables and they've got like couple of hundred columns on there, right? Writing out the inserts for them is a bit painful or a bit fiddly. So if we're going to provide, we've got a 100 column table, we're going to provide all the columns and all the values, we have an insert statement that looks a bit like this. Okay, not the easiest to spot what's going on here. So I've been nice and following my practices, provided all the columns, provided all the values, but I have made a mistake here. There's actually an error in this insert statement. Can you spot it? It's not very easy, right? There's a little subtle mistake hiding in here. I've got the values for columns 64 and 65 the wrong way around. So this can be really tricky to spot when you've got inserts where you're providing large numbers of values. And it can be tricky to test as well, particularly when you've got several consecutive columns which have several similar names and values. Things like insert various dates. So invoices can have like the insert date, the raise date, the paid date, various similar values like that. And in a lot of situations, they might actually all be the same value. Particularly in retail environments, the invoice might be generated and paid all at the same time, 95% of the time. It's fairly rare that you actually have it paid later. So you can end up with these subtle, hard to spot mistakes where you've accidentally got some columns the wrong way around. And you need some pretty thorough testing to make sure that everything is actually going in the right column and the right place. I know very early on in my career, getting caught out by something like this. I had an insert, I forget how many columns there were, but there was lots. And it took me ages to track down that I'd accidentally got down the values for two columns the wrong way around. So this is a bit tricky, and providing the column list here is good practice to prevent code failing if we add or remove columns, but it kind of actually doesn't make a huge amount of difference to transposing things here. still easy to get things the wrong way round. Be nice if there was a simpler way to actually load all the values into a table at once. And good news is there is. Using PL SQL, we've got this row type anchoring. So what that does is you can declare a variable and then table name % row type, and it is a record with all the columns from that table. So we can do something like this. We can declare a table record for the row type of it and just insert that. And this will then have exactly the same attributes and data types in the record that the table has in the columns. So you know that they are identical. Now, there are some little caveats and gotchas to be aware with this. So I'll come to those in a minute. So we can use this row type to provide the values for every single column in the table. And we know that the record type and the columns stay in sync. So if we change things, we don't need to go and change all our code necessarily, at least. But as I said, there's some gotchas with this. First thing to think about is what happens if we've got default values for columns? You know, what happens to those when we insert to the table? So let's create a simple little table with two of probably the most common defaults that you'll have. Some kind of auto-generated primary key, either using a sequence, as I've done here, or an identity column, and the insert date for when you're adding rows to the table. So they have default values. So there's a couple of ways we can actually provide those defaults. One is to use the default keyword. So instead of inserting a particular value, a literal or a variable or something like that, you can just literally put in default and it will insert whatever that default value is. The other way here is we've only provided the value for the primary key. We haven't listed insert date. So any columns that you haven't listed will get the default value. So both of the columns in this insert get the default value. Now, seems pretty straightforward, but what happens if we try and actually insert the value null? Okay, now ID is the primary key. You can't have null values in the primary key. So what's going to happen? We're going to get the cannot insert null into this, right? So this is disallowed. And this is probably one of the first gotchas or little things to be aware of with row type inserts. Implicitly, we've declared that record and it's got every attribute. They are implicitly null, so they have no value. So when we try and insert it, what happens? Well, it's all going to fail. It's not going to be able to use those defaults because we're actually supplying the value null for every single column in the table. Not good, right? Fortunately, back in 12.1 now, we had this little tweak to the default syntax, default on null. So now if you explicitly provide the value null, it will still actually get overridden with whatever that default is. So this is great for these record type inserts. Also, lots of frameworks tend to provide values for all the columns, and if they're not set, use null as well. So there's lots of situations where this default null syntax can be very useful. So that's great, we can insert these defaults, but the next question probably comes is, well, what were these defaults? You know, particularly if you're inserting the primary key, an auto-generated primary key, you probably want to get the value of that so you can return it to the client so they can look up the record or just know what they've inserted and so on. So you want to fetch that value back. And a lot of people have this question, like, how do I get the last row inserted into the table? That's not what you need to do here at all. There's actually a very simple way you can get the values you've just inserted to the table, and that's with this returning clause. So for these default values, we can return their values. Here I'm just doing it back into the record itself. You could do it into any variables you want, really. They don't have to be the record variables. So this gives a nice way we can build a little API for single row inserts. So at this point, I'm going to jump over to a little demo showing you how all this works. Now, see, there's a question from Richmond. What's the best approach to select all records from a table at once and insert into a different table? So I'll come back to query-based inserts later, Richmond, sorry. So keep that in mind, and I'll talk about that a bit later. And then if you've still got questions, let me know. So let's create our sequence. We're going to have default and null for the primary key and the insert date. And now if I do default insert, so we'll get the sequence value for the primary key, and because we haven't specified the insert date, that will get sysdate, so time now. So let's just run those and we can see we got those values, the insert date and the primary key. Very nice. Okay. So let's now imagine we're building some simple APIs just to do single row inserts. Now, if we do just a standard, normal values insert, where we're providing things like this, we can do all the defaults, return those, and create that, or we can do a record insert. Now, here I'm going to make this record variable parameter, an in out, so we can pass it in and return it back out with the values actually populated, those default values populated. So we'll run both of those, and we can use both of these. So with all the individual values, we can insert a row, insert 2, and with the record type, again, we can insert those values, again, inserted 3. So let's now add a column to our table. Let's do insert column 3, and notice here, I've been very naughty and not provided the column list for this thing here. So actually neither of them have the column list, but the basic row values, providing all the individual values, is now broken, right? The procedure is invalid. It doesn't work because there's a mismatch between the columns it expects and the values we're actually providing. However, our row type insert just works. It all just works. That's nice. So this can be a good way to build kind of APIs here. Okay. So any questions or comments on that? I see there's a comment in the chat about this. So from Annabelle, Chris, sorry, since when can you use the on null clause? So the on null, the default on null is 12.1. Okay, so I hope that answers that. Okay, indirect, can return full row type? No, so you do need to specify which columns you are returning. Okay, so there isn't a returning star, or for example, or at least not that I'm aware of. And if you're passing in a record, actually there's probably relatively few values you actually want to return, right? It'll be primary key, insert date, maybe some other defaults. So if you've got a 100 column table, chances are most of them don't have a default value, right? So you don't need to return it because the value is what you passed in. Indrek, when I have a trigger, the full row type is important. Maybe if you expand on that a bit later, we can discuss that in more detail. But okay, so from Anonymous, how does the record type handle the null values, unspecified columns automatically? So the row type here, this implicitly has the columns in the table. Okay, so it matches whatever the columns are here. So it's saying, T, this record has the same columns as this table. Little asterisk, which I'll come to in a minute. And when you declare a variable of that row type, then it has all those attributes. And until you actually assign them a value, they are null, right? They are just like if you declare any variable, like n number, until you assign it a value, it's null. Until you assign these record variables a value, they are also null. Okay. Joseph, being able to return a row type would be variable because you would get values that could have been changed by a trigger. A lot of people mentioning returning values returned by a trigger. I'm intrigued by this example. But if this is something you want to see, then please submit it to the Database Ideas Forum, because that's a good way we can gauge community support for features like this, right? Maybe if I've got time later, I'll pull out the link. So if you can submit them there, we can gauge and see how many other people think things like this are useful. Okay, but yeah, it is noted it would be useful in some scenarios. Okay, so let's go back to the slides. Right, so we saw ideally you'll have a basic insert with a column list, or maybe you might use row type. Now, there's a good chance you've got a whole bunch of legacy code out there which you'd like to change, but you can't for various reasons. And a lot of them might have these inserts with no column list. Okay, so they haven't provided what all the individual things are. This then creates a problem if you want to decouple table changes from code changes. So personally, I think it's a good idea, making some changes, so going to have some change to the database. You deploy your schema changes first, then make sure they're all fine. And when you're happy, that's good. Then deploy the code changes. This decouples them. So if there's any problems, rollback's easier. It's easier to identify the source and so on. But in order to do that, we can't just create these new columns, right? Well, there is a little trick available. We can declare columns as invisible. So what this means is they are hidden from generic table access. So select stars or inserts without a column list. Okay, so if we've only got 2 columns in our table here and we add a third, our 2-column insert will still work because that invisible column is not considered. So that's great if we just want continuity and not have our whole application fall over. But it does create a potential issue when it comes to these row type variables. This is also a form of generic access. So invisible columns are not included in these row type variables. So what happens when we try and assign that a value? The whole thing falls over in a big heap because it doesn't exist in that variable type. It's in the table, but it's invisible. It's hidden from generic access. It is physically there, but we can't get it in these generic access methods. So this is one problem with these row type inserts. There is another problem, and that is virtual columns. So you can define columns which are an expression. So they're not actually storing a value here. What we're storing here is the result of this. So returning the start of the month for that column, whatever it is. These are only calculated at runtime. The value for them is not stored. Now, critically, because we're not storing anything for these, it also means we cannot insert anything into these. So what happens if we add that and we've got a row type variable? Well, we can't do our row type inserts anymore, right? Insert operation disallowed. So these row type variables or inserts, very handy, makes it much easier if we've got these tables with loads of columns on. But there's some little gotchas here, some little things which can make them more fiddly to actually work with. So does this mean like the whole approach is like dead in the water? Well, there is another trick we can use here. So you can insert into a regular table, but you can also insert into a view with some restrictions that we'll discuss in a bit. So we can insert into a view. So what we could do is, let's say we got a table with some invisible columns and some virtual columns on it. So when inserting, we need to exclude those virtual columns and include any invisible columns we want to supply values for. So we can define a view which has the exact columns we want to supply values for. So as I said, exclude the virtual and include any invisible that we want to supply for. And actually, if you've got a table with 100, 200, whatever columns are, and typically you only actually supply values for maybe, 10 to 20 of them, you could use this as a way to do row type based inserts for the common columns which are always supplied, and have that as a kind of generic access as well. So we can create a view like this, and we can use the row type on the view as well. So we can actually do an insert on the view using a row type of the view, and that will go into the table. So this is, a one way kind of around this kind of scenario. So, but there are some gotchas. So with these views, as I said, first to be aware of is what happens if we've got a where clause in this view. So here I'm doing something a bit weird. I'm trying to find all the rows inserted after now, so all the future dated rows. I know. I'm not sure why you'd have this in a real example scenario, but it helps demonstrate a little problem here. So we're using a default of sysdate for insert. So any rows we insert using that default will not be returned by this where clause. So we can insert a value that we cannot select back from the view. Interesting, right? Those of you who follow me for a while probably know I like my SQL magic, and I think they're good, fun ways to demonstrate principles or things you can do with SQL. But this is definitely the kind of magic you don't want in your real world application. You've got some users complaining, they're trying to insert values and then they can't query them back. If you're not familiar with the system and you're not sure what's going on, it's the kind of problem you can easily sink, a couple of hours on, maybe even more, depending on your environment. You're like, well, I can insert values, I see them in table. Why, what's the real problem here? So you can insert values into a view that you can then not query back out again, which can lead to some interesting problems, shall we say. It'd be good if we could kind of prevent this. There is an option to do this actually, and that's this with check option. So what this does is it checks when you insert a row into that view, does it meet the where clause? If it doesn't, so we're trying to insert a value you cannot query back, you will get an exception. So you no longer get these kind of disappearing rows and vanishing on you, which can be very useful in some scenarios. So we try and insert a record type of this view. It uses the default, so it inserts sysdate. We can't query that back because we're only looking for things inserted after sysdate. So we get an error. We get a with check option violation. So very useful if you're trying to do inserts against views that have where clauses. But this kind of only really applies if you've got a single table in the view. Views can be really complicated. I mean, you could put any SQL statement you want in them, really. So what happens if you've got multiple tables? I said complex views here. I really just mean anything that's got more than one table in that view. Let's say, for example, we're trying to do a join. We're joining two tables. We've got parent and child, and we will return those rows. Can we insert into this view? Short answer is, it kind of depends. It depends on what you're trying to do here, right? If you're only inserting rows into the child table, then you may be able to, but you can't if you insert into the parent table. Why is that? Well, because we're joining here one-to-many, each parent row could appear many times in the results of this query. So you're not allowed to do that. There must be like a one-to-one mapping from the values you're inserting to the table, the rows that are actually going to go into the final table. So we can't insert into the parent because we don't have that one-to-one mapping. Child table, we do have that one-to-one mapping. So it is possible to do this if you've got appropriate constraints. So there are some little interesting quirks with inserting into these views. So let's say you can insert into one table pretty easily. And if you've got virtual columns or invisible columns, they're a nice way to use record type inserts to only provide values for the columns that you need. So very useful there. And the with check option, it's a little known option, but if you've got a where clause and you're going to do DML against that view, I'd recommend you use it to kind of avoid this kind of disappearing or vanishing row problem. So using one table, that's pretty straightforward. And this is actually a good kind of principle or technique. You can use this to kind of virtualize your schema. Those of you who are familiar with edition-based redefinition, that's actually kind of the principle it uses. Create views on top of tables to decouple the schema changes from the actual kind of logical data layer that we have. If you're not using EBR or you don't want to, whatever, you can roll your own views as a way around this. That works if you've only got one table, but when you've got many tables in your view, there are more restrictions. Firstly, if you've got two tables with a one-to-one join, you can only insert into one of them at a time. You can't insert to both in one insert statement, so you need to separate those up. And as I said, the target table must be key preserved is the terminology we use. So there's a one-to-one relationship from values you are inserting to rows that will actually be in the target view. So you can't insert into a parent. And at this point, a quick note on triggers, okay? The view is sort of a bit like a pass-through, particularly in the simple case. Any triggers you've got in the base tables will still fire. But if you want to do inserts on these complex views, one way to do that is to define instead of triggers. So these intercept your insert statement and run a different insert altogether. So at this point, I will jump back over to a demo to kind of talk a bit, show in a bit more detail how this works. And I see there's a big comment from someone in the chat, from Sven. So Denise, or whoever did ask about select from one table and insert into another. Okay, yeah, I'm going to talk about inserting selects in a minute, Sven. So I will discuss that. We'll come back to that in a bit later, maybe. Alrighty then. Okay, is there any other comments? So Joseph, could you also insert directly to the table using a variable view dollar row type that includes the invisible columns? There has to be a match between what the table expects and what the row type is, Joseph. So if there's no invisible columns, there's no virtual columns, and you just select all the columns in the table in the view, then you can actually use the view instead of the table. I'll have to check actually what happens with view. Maybe I'll have time to do that. All right then. So we'll have a look in a second. All right. So we've got our table here. We've got our third column that we added. Let's go and make it invisible. And I'm also going to add my virtual column. So we can now insert values into this invisible column as long as we explicitly specify it. Okay, so we can put values into C3 and they will go in. Although if we do a select star, because it's invisible, it doesn't appear. We have to explicitly request it in our select clause. So there we go. We can see we've inserted a value, that value along those defaults. Now, if we try and rerun our APIs at this point we defined earlier, they're both going to break because we've got that virtual column. So our plain values insert, where we're assuming all the columns, that's invalid, that's broken. And just kind of show you with these invisible columns what happens here. They are not a component of the record, so we cannot access this in our row type variable. Remove that. Okay, this will work, maybe. No. Okay, the insert is disallowed on the virtual columns. Okay, so we're still in a bit of a bind here. Okay, so let's try and create our view. So we're going to include our visible, exclude our virtual, and we can now actually pass the value for the invisible column because it's now actually visualized in the table, in the view, I should say. It's a real visible column. In the view, it's invisible in the table. So we can do this now. And if we select from the view, we've got that value 99 going in. And in the table, well, we still can't see it doing select star. We have to actually select the column explicitly. So Joseph, could you direct using variable view type that includes visible columns? So let's try. We've included the invisible column here, Joseph, and I think, yeah, that's going to, yes, because we've now, it's assuming we're passing a value for that virtual column, so that isn't going to work there. Let's just change this to be invisible as well. Insert month. Let's change that to be invisible too. So we could hide that virtual column. And I suspect we will find, yeah, it's not going to work because there's a mismatch between the view and the table. They've got different numbers of columns, so we cannot do that, as I suspected. Alrighty then, let's go back. Can we add our with check option now? Our slightly bonkers where clause, but critically, this now means that we can't insert that row because we're using a default and it doesn't let us do that. If I do trec, what's it called, insert date, this date plus one, we can insert a date in the future. It will allow it because it passes the where clause. Okay. Let's do some complex views. Let's create a child table and create a view over the child. Notice only selecting column from the child. That insert will work because there's a one-to-one mapping there, and the database knows there's a one-to-one mapping. So we've inserted a row in the child. haven't got the foreign key set, unfortunately. As I said, database knows about it. It needs these constraints, the foreign key and or the unique primary keys to actually know that there's that one-to-one mapping. If I remove those, this is now going to fail because the database doesn't know for certain that each row from the child table will appear at most once in that view. It doesn't have that information to make that guarantee. But regardless, we cannot insert into the parent because there can be many rows there. You know, that's going to give us this non-key preserved row table error as well. If we want to now insert into the parent anytime, or the child, now we've removed all those constraints, we can create this instead of insert trigger. So we're intercepting it and sticking it in the parent, and that now will work because instead of actually trying to insert into here, what it does is run this instead. Okay, and there we go, we've got the columns. All right, so various questions. Let's look at these questions. Okay, Niraj, could you also please show how to use ref cursors to insert records? So you can't like insert a ref cursor directly. You have to actually iterate through it and populate the values. You need to fetch the values out of the ref cursor and then actually supply them. If you need more of an example on that, we might have some time later, but you can't do insert into table values ref cursor. You have to fetch the values out of the ref cursor and then insert those. Okay, Sanjeev, when we deal with EBR views, what would be good practice? Should the view name for each EBR be different so that we can keep the same name, so the column differences in different EBR version can be handled properly? I'm not sure exactly what you're asking there, but basically, for those of you not familiar, edition-based redefinition is a zero downtime deployment technology. So you can make schema changes and change a schema without having to take the and leave the application up and running. And one of the key ways it does that is by having these views that are above the tables. So then each time you create a new edition, so essentially you can then have versions of these views in the different editions. The name of that should remain constant. Essentially, the best way to do this is do something like quote the table name and lowercase it, and then create the view with the same name as the table, unquoted, so it's not case sensitive. Then your application code can remain the same. But the whole point is you can change your schema without actually then having to go and change all your code. So if you change the names of those views in different editions, then you're going to have to change your code, which kind of defeats the point, okay? So if that's your question, should you rename the view in each edition? That's completely not what you should do. You keep the same name, and in each edition, you can change which columns you select from the view. This is a big topic. We could talk about it in a bit more detail in another session possibly, but you definitely do not want to be renaming the views in each edition. Okay, so I hope that answers what you're trying to do. Jamal, wouldn't the triggers have context switching? So how would that affect multiple row inserts? Yes, when you have the triggers, if you've got the SQL, triggers appeal SQL, so they will have to run for each row. So you're switching engines and overhead of that. It's not going to be great for performance. So this, instead of insert approach, I would say this is probably more of a tactical solution than a strategic solution. You know, let's say you've split one table into two, and you've done the schema change, and you're deploying that, but you want to keep the code the same, so rollback's easier, that kind of thing. Then you could create this instead of insert view. This is something I have actually done something like this. But the idea would be then eventually you probably would separate, change the application to go directly against the tables. You may disagree, you may think that go ahead and do this against the views themselves and just use these instead of insert triggers. Personally, I wouldn't use this as like a long-term solution. It's more of like a stopgap or something to get you from where you are to where you want to be. That's kind of my opinion on this. From Sven, performance tip, use the default on null value for columns on tables to avoid insert triggers. If you can get rid of the trigger by doing it this way, instant performance goes way up. Yes, great advice, Sven. You know, if we go back up here, a lot of people still will write triggers to populate these values, insert date and primary key value, right? You absolutely should not be doing that, you know, in 2021. Okay, you should use the default on null if necessary for the sequence or identity column or sysdate, and then you can remove these triggers. There might be some situations where you still need to do something a bit complicated in them to set default values, but they should be pretty rare. I mean, my experience is mostly just these, maybe a few other kind of fairly straightforward defaults. Oren's sharing his link about his 2 cents on naming tables and additioning views in EBR. Thanks, Oren. I'll post that again later, probably share with people. Okay, all right, so good questions, folks. All right, I've still got various things I want to cover, so let's truck on. So far I've been talking about single row inserts, and they will usually be the case when you've got an application writing to the database. You might have, often you'll only insert one row at a time, or maybe the parent and many child rows, but usually it's a handful of values that you're inserting at once. What happens if the source of the data is another table or a file, particularly a file you've exposed using an external table? Well, now we can talk about multi-row inserts. So basically here, we're inserting the result of a query. The way you do this, very similar to single row inserts. You insert the table with the column list and you run your query. Right? So pretty straightforward, really, and it just loads the results of whatever that query is. Now, a question we had coming in advance about this is, well, how do we know how many rows we actually loaded as a result of this? There's a nice little easy way to do this. There's this SQL %row count attribute. So if you're running in PL SQL, you call that, tells you how many rows were changed. If you're using like JDBC or sending the inserts from the mid-tier, a lot of those contain something that will return the number of affected rows as well. So SQL %row count in PL SQL is the thing you want to look for. All right, so let's look at one of the probably more interesting examples, and that's loading a file using an external table. So we've got a CSV file, we got an external table over it, so we can query it and load that into the database. And it's reasonably common for these files to contain different record types. Okay, so we've got record type indicator, and depending on what that value is, it determines which table we are going to load the data into. So we'll have a table for these 11 records, and 99 records will go in a different table. So we could write separate inserts for each one of those. So we query the table, external table for that record type, and insert into the appropriate table. Pretty straightforward, and it does work, but there's a bit of an issue here. We are accessing that external table twice, or at least once per target table we want to load into. And we're like, what's so bad about that? Well, your tuning options for external tables are very, very limited. You can't create indexes on them, for instance. So potentially, well, you will be reading all the rows from that external table in that file many times. And that's a big file, could lead to a lot of wasted effort. It'd be nice if we didn't have to run it multiple times. And one way is to like load it into a table, a real physical table first, and then query that, but that adds some extra processing as well. You can actually load into many tables at once with a multi-table insert, something like this. So insert all. Now, if I just do insert all, that will literally insert every single row the query returns into every single table. That is not what we want to do here. We want to do this conditionally. So rows only go in the appropriate table. So we can do that with the when clause. So it looks a little bit like a case expression. It's not similar principle. And we can say if they're of this type, go into that table. If they're in that type, go into that table, that kind of thing. So this is pretty handy. But one thing to note here is it's possible that one row from the query could match many of these when clauses. You could actually have multiple matches here. It will go into every single matching when clause, okay? And some cases that might be perfectly fine, might be what you want here. But for something like this, where we're saying the record type determines the target, well, you want to be sure that they only go in one table, right? You want to be sure that record type 11 goes in table 11, whatever that's called. So we can swap that for first. And what this does is it evaluates those when clauses top to bottom, and it'll insert into whichever table or whichever one of those first matches that where clause. So these are mutually exclusive. So if you want to be sure that each row returned by that query only goes into one table, insert first. If it could go into many tables, insert all. So this is pretty neat. And at this point, a lot of people then kind of go, well, actually, I've got some denormalized data and I want to normalize it into a parent and child relationship tables. So could we use this to insert into parent and child at the same time? And the answer is sort of. Okay, right. You can, but there are a lot of gotchas with this. So first thing to note here is, let's say we've got some source data and we want to split it into parent and child. So normally that parent row will be repeated, parent values will be repeated once for every child row in the table. So we want to ensure they only get inserted once. So we need to do something like this, have a row num thing in there and only insert into the parent once, but always insert into the child. So 1 equals 1, always true. We will always insert every row from the query into the child table, but we'll only insert one row from the query into the parent table. So already it's kind of looking pretty fiddly here, right? There's some other little gotchas to be aware of as well. Perhaps one of the biggest is you cannot select sequence.nextVal. So we need to know if we're generating the parent primary key values we need to know what they are to actually insert them into the child table as well, right? Nice if we could select that. Unfortunately, you cannot do that. So getting a bit trickier to write. Next important thing to be aware of is that with insert first, multi-tables go top to bottom and process the statement that order. With insert all, the actual order it chooses the tables is indeterminate. That is by definition, that's part of how it works. It doesn't say it goes parent first and then child. It could insert to either table in either order. So that means potentially it could insert to the child before it inserts the parent, which means you get that foreign key error, is it 2292, whatever it is. So to use this, to be sure it works, you need deferrable foreign keys. So I think this is a great point to jump back over to another demo. So let me scroll back down. I see there are more comments. Let's see, what's it say? Some compagnie. Suppose I have a table with a single column primary key, identity column with auto-generated values. Insert all fails because the server requests one single value from the built-in sequence. Is there a way to insert all several rows using auto-generated columns? I'm not sure what the issue is there. You can insert several rows with, if it's a default value, you can insert several rows. So I'm not sure exactly what the situation is there. If you could maybe do some pseudocode or something, that would probably help. I mean, can you have a session on bin fitting knapsack overlapping row solutions? Maybe one day in the future. They are kind of advanced topics. I'll be doing some basics for the next couple of months at least, but yeah, I'll bear that in mind. All right, let's truncate these tables. Let's truncate these tables. So let's just do a basic multi-row insert. This query returns 10 rows, and we'll insert them all into the table. And we'll use SQL% row count to see that we did indeed load 10 rows. There we go. Okay, and we can see we've got them in the table. So now we can use insert all, and we're inserting just one row here, and that row goes into both parent and the child. So parent and the child. Notice we haven't specified the foreign key value. Okay, try and pass that in sequence. Doesn't let us. Sequence number not allowed here. Oh dear. So you have to kind of pre-populate that sequence, pre-generate it to be able to pass it here to both of them. All right then. So you remember I dropped all those constraints before. Let's add them all back. See what happens here. I'll also alter the table a bit. So I've got table here, query here, which returns 2 rows. I want 1 row in the parent and both of those go in the child. So we're doing a row num equals 1 to get 1 in the parent and both those in the child. What happens here? We get the 2291 error, right? Because the order is indeterminate. It's trying to insert the child before the parent. We've got an error because that primary key value does not yet exist. So that those rows have not gone in. But fortunately, I declared the foreign key is deferrable. So we can set it to be deferred, which means it's checked at the end of the transaction. And those rows can now go in. So we get 3 rows inserted. Set constraints immediate, so we'll check then or when we commit. And we are now hunky-dory. So we can use these multi-row inserts to load split rows into parent and children. It's just a bit fiddly and various glitches to be aware of. So Neeraj, what are specific scenarios when instead of triggers need to be used? It's when you can't insert directly into the table. You know, that join parent to child, you had to do it if you wanted to insert the parent because the parent table is not key preserved. Also, if you any kind of complex query, it's a bit vague about what that exactly means, but anything involving multiple tables is probably need to do it because the way the database works and how it processes that. And if it is not able to identify a one-to-one relationship, you're saying insert into the view this one value, does that map exactly to 1 row in 1 target table? And are there constraints on that table so the database is able to identify that? If no, then you will need an instead of insert trigger. So hopefully that answers that question. Okay. I think have I blown your mind a bit here with all these insert all multi-table inserts at this point? Like, you said this was basic, Chris. What are you doing here? Yes, as Oren says, you can use next val in each of the into branches and it will use the same value for each source record. Will it? Is that right, Oren? I thought it used different values. Maybe I'm wrong. Oh, let's see. So yes, he's right. Yeah, I'm just going to try it. S.next val, and let's do S. I set my constraints deferred. Okay, let's see, 2 child, and that has got 26. And 26. Ah, you're right. I didn't realize that. Thanks, Aaron. Let's just double check. Yeah, 27 and 27. Very nice. Okay, cool. Very good. Thank you. All right, there's one big topic I want to cover off before we finish, and that is performance. Okay, so first thing to note is single row inserts are very, very fast. Like they take microseconds to execute. If it takes any appreciable amount of time to insert 1 row, you have got a problem, right? So in terms of code perspectives, there's 2 common things that could be. One is there are triggers on the table, right, and which are doing a lot of work. That's probably the most likely reason if inserting 1 row takes a long time. Or you might be blocked. If another session is trying to insert the same primary or unique key value and is not committed, you might be blocked on that. So in terms of code perspective, those are the 2 most common. If those are not an issue, you might have some kind of hardware issue. So single row inserts are mighty, mighty fast. But do them lots and lots of times and they will get slow. Okay, so as soon as you put SQL inside of the loop, you have got the potential for slow code. So you don't want to be doing this. You don't want to be doing an insert inside a loop. Now, if you've got an array of values coming from a client, for example, you can use for all instead, bulk inserts. What this does is it executes all the inserts in one switch from the PL SQL to the SQL engines. This is significantly faster. I've got a little demo. I'll show this in a minute. So that's single row inserts. What about inserting a query? Well, the first thing to note here is, of course, you've got a query. Check how long it takes to run the query itself on its own without the insert. It might be that just processing that's going to take time, and it might be slow because of the query. So tune and optimize the query as you would do normally. Assuming that's fine or acceptable or good enough, some things you might want to look at here are running the insert in parallel or using direct path loads. Now, at this point, a lot of you are probably at least familiar with what the concept of parallel means, but you're like, well, what is direct path? What does that mean? Well, let's imagine we've got our table here. So we've got our black blocks, which are completely full, white ones, which are empty, and these kind of gray ones, which are partially full. So our high water mark for the table is the highest block in the table which has had data inserted into it. If you do a normal or conventional path insert, it will search for free space below the high water mark before inserting the row, if there is some. So we'll use one of these kind of lighter colored patches. Direct path inserts always go above the high water mark. So don't search for free space, but it also bypasses the buffer cache. So both of these things can add up to some performance savings when it comes to inserting data. And here I've got some quick demos I want to show on these as well. So first thing to show what I'm running, I'm on 21C. I've got my I'm on my cloud instance, a E high performance release. If any of you've got credits you want to try this out on, and just to show, insert a single row is super quick. It's so quick. It gives no time as a response time. Obviously, it takes time, but it's just too quick to actually execute it. So let's do some tests. I'm loading some data here. I've got some source and target tables. Let's do that. 7,500 rows roughly. And I'll start this off. So first up, I'm doing an insert in, well, I'm going to load the array up with 7,500 records, do an insert inside a loop, do a for all insert, batch insert, and then insert the result of the query. And you can see the loop takes nearly 6 seconds. Both the other approaches take a quarter of a second roughly. So, 20-ish times quicker. So anytime you're inserting lots of rows in one go, you absolutely want to avoid putting it inside a loop. You want to use bulk processing if it's coming from a client, or insert select. All right. So how can we tune this insert select? First thing I want to check. So we can use this parallel insert. Now, you'll see these PX coordinator stuff. A couple of interesting things going on here. Notice it says load table conventional at the start. Okay, that means it's not using direct path inserts, it's using conventional path, but it's also not doing the insert in parallel. We actually have to enable parallel DML. So I'll do that. It's going to complain at me. There we go. Let's actually enable it this time. And we get the execution, the explain plan here again. You'll see the load as select is now partway through. We've still got parallel operations above it. So we now have parallelized the insert as well as the query. So this, originally we were just parallelizing the query. Now we've parallelized both. Also, it's saying load as select rather than conventional. So that means it's direct path. By default, parallel uses direct path. Okay, you need to make it disable it if you want to avoid that. And so we can run that, and it's pretty quick. But there's a problem where, oh dear, we get an error, right? Why don't we do this all the time? Because we get this error. You cannot then reference that table in that transaction until you commit. So we can see we've got an exception there. I'll just do like this. Cannot read or modify the thing. So that's not great. So you can't just enable, and this applies to direct path as well. So you can't just enable these for everything, for every transaction, because a lot of times it'll break your transactional processing. Okay, so it's one thing to be aware of. So I've multiplied, I'll do some performance tests here. I've loaded up to about 2.5 million rows and 400 megs of data. And this process is going to take a while. So I'll just start that running. I'm going to run this a few times. So we'll just do a plain insert select, a direct path insert select, a parallel conventional one, and a parallel direct path. And this is, I have to cross my fingers a little bit with this and hope it gives the results I want it to, because there's what else is going on in the database can affect this to some extent. So as I say, this will run for a couple of minutes. So if there's any other questions or comments, now is a good time while we wait for that to chunter away. Okay, from Judith. It looks to me that the foreign key violation for insert all is a bug because constraints supposed to be checked after the statement was completed, and insert all is still a single SQL statement, isn't it? There's a bit of an interesting history with this situation, Judith. Jonathan Lewis has a blog post where he talks about this in a lot more detail, but there are some bugs logged for it. Some of them have been closed as not a bug. So this is a interesting / slightly controversial thing. Maybe if I can dig it out, or if someone can dig that post out and share it, he talked about all the details of it there. So Hemant, whether a parallel path insert blocks conventional inserts by other sessions concurrently. I don't believe so. Hang on, I'll just start a new session. If we load this up, there we go. I will just do a straightforward one. There we go. Oh yeah, so it is actually, it is blocking. You're right. Yeah, so you see that's blocked and waiting away for that to finish. So yes, good point. Can you talk about timing package? It's just a little utility I wrote. Basically, beforehand, it just does dbms utility get time, and afterwards it subtracts the start time from the difference. That's pretty much all there is to it, with a bit of formatting of the results. So it's a nice little handy thing I've written there. Okay, I've got the results at last. Here we go. So, oh no, it's broken. Oh no, oh no. Ah, dang it. Oh well. Okay. No. All right then. We are at the hour. So if you need to go, I'll feel free to go ahead. I'll run this again because that is now broken. That helped show some of the issues that potentially may arise here. And actually, that's going to be from the truncate, won't run because we've got that uncommitted session. So if you need to run, I will just wrap up and then I'll come back to this because this will take about 3 minutes to run. Okay, so as I say, we talked about inserts. So when it comes to single row inserts, they'll be kind of bread and butter, most application inserts. Using record types can make it a lot easier when you've got lots of columns, but there are issues surrounding those when it comes to invisible and virtual columns, lots of little gotchas you need to be aware of. Using a view to insert instead can be a way to help simplify those. It's also potentially useful if you've got a table with hundreds of columns, but most of the time you only insert like 10 or 20 of them. You could use a record type of the view to provide those values and worry about the others later. Multi-row inserts are where you're loading the result of a query. So you insert select, okay? And that is the most common, but you can also use it to load many tables at a time with all or first. So first, the rows will go in at most one table. With all, it will go in, well, it could go in every row, every table. If you don't have the when clauses, if you do have the when clauses, it'll go in every matching when clause. So think carefully about what you want here. When it comes to performance, single row inserts are mighty quick, and there is almost nothing you can do to make them faster, right? Very few tuning options you've got available there. Thing is if you were doing a lot of them at the same time, particularly in a loop. To avoid that, you want to use bulk processing for all NPL SQL, or insert the result of the query. If you are inserting the result of the query and you're processing lots of data, you probably want to look at parallel or direct path loads to help improve the performance of those. And just to kind of, hopefully at this point, the demo will actually be still running. Okay, so that's going to be running away. Give that a minute or so to finish up. Any other final questions or comments while we wait for that to end? Indrek. Is there some trick to use returning when using insert into select, and select returns only one row? Example, copying one row. So the returning clause does not work for insert select. It only works with insert values. Okay, so it is currently unsupported with insert values. So if you need to know what those values are, you actually kind of need to select them first and then insert them. Perhaps by doing, select bulk collect and then for all insert is probably the way to go there. And then do whatever you need to do with the results there. Alrighty then. And so it's vanished at last runtime. So first thing, I had the plain select statement on its own, just to show that that chews up a fair bit of the time. And you can see the plain insert select, the actual select is roughly half the runtime. So 22 seconds select, 44 seconds to actually insert select. When we got the append and parallel, they both reduce it a bit, not massively so, but a bit. But it's when we combine both of them that we get the full improvement. Now, parallel is one where it's not going to magically make everything super fast here. So I'm running this on a 2 CPU cloud instance. So really, we can only get 2 threads running at a time. If you enable parallel on a system where you've got very few resources available, there's lots of other sessions going on, it can make things slower because you're all competing for the same resources. You need to make sure you have enough resources available to make sure for parallel to actually help. And it does tend to be a case of diminishing returns. Each doubling, you're going to at most half the runtime, and you probably won't even do that. So you need to kind of play with your system, see what resources you've got, find out what benefits you get. But you see, by combining those, you can get some good performance benefits. So Rachel, how does bulk collect fall into this? Okay, so that's a good question. Rather than just doing insert select, I could have selected bulk collect into a record and then afterwards done a for all insert. For something like this, where I'm not changing the values or doing anything with them, that is a waste of effort. If I need to do some manipulation of the data that I can't do in SQL, so I'm going to select the rows into a record array, and I want to manipulate it or process that in some way, then that can be a benefit. Also, sometimes I might want to use the rows not just to insert into this table, but also to do various other processes with. Now, as I said, you can't insert select and return the values. So if I need the values from this table to do other things, I might want to bulk collect them first, do the insert, for all insert, and then do whatever else it is I need to do. Things like sending emails, iterate through the array to send those emails, or something that I can't do in SQL, basically. So Rachel, you're saying for performance purposes, I'm not quite sure exactly what you're saying here, but primarily you're using bulk collect to avoid doing something like this. So for IN, select star from, source T, right? That is, if you find yourself ever writing this, stop and think very hard, because you probably shouldn't. Okay, if you need to do, either you want to plain insert select, or are you doing complicated stuff besides just an insert, which you need these values for, then bulk collect as well, you'll do that as well. Comment from Sven, big sequence cache is also useful to improve insert performance. Very good, yes, great point. I didn't talk about that. And 21C, we actually now have dynamically sizing sequence caches. So hopefully that will alleviate or reduce that problem a little bit in the future as well. But yes, good point, Sven. All right, then. Any other? I think that's everything. I think that's everyone. Everyone else. Alrighty then. In which case, I will just. I've got. If you want to, I don't have the scripts from this session, but I do have a few live SQL tutorials already, which have very similar scripts in them. You'll find, Rachel, if you want the timing package, you'll find a very similar version. I keep iterating and changing it, but in that tuning inserts live SQL tutorial, you'll find a version of that timing package in there. Richard, yes, the recording will be available later, probably be sometime tomorrow, certainly sometime later this week. It will be available. So you'll be able to check up and review this. I'll share the links and so on the office hours page as well. So I think that's it for today. Thanks for hanging around. We're quite a bit past the hour now. So do hope you all enjoyed this. More importantly, I hope you learned something. As always, stay safe. Hopefully, when things slowly return back to normal, we'll actually be able to meet and see each other in person sometime. Stay safe and see you soon. Goodbye.